So we'll start with the discussion of weekly homework from page 15 to page 30. If you have any question or doubt, this was a last week homework related to topic motion. You can mention your doubts if you have. Let's start with page 15. If you have any doubt on page 15, any part, you can ask. Page 15, part B2. In part B2, the question is show that the difference in the height between point A and B is 3,200 meters. And the component of the velocity is given. So as we have the component of the velocity first, what we do? We will resolve the velocity, the horizontal and the vertical components. So this velocity is having the component, like example, this one is 47. So this will have the two components. One of the component is with an angle. One of the component is with an angle. So that means this will be equals to 47 cosine 24. And another one is against the angle. That will be equals to 47 sine 24. And we need the height. And already they mentioned it is moving at a constant velocity. So if the velocity is constant, we have the formula like speed is distance divided by time. So if I need the distance will be speed multiplied by time. So what we have to do, we just need this height h we need, or the distance we need, which is speed multiplied by time. So what is the speed here? The speed is 47 sine 24. And what about the time? In the question they mentioned it took 2.8 minutes. So 2.8 minutes we have to convert into second. So 2.8 multiplied by 60, so the time will be in second. So the vertical component of the velocity multiplied by the total time it took to reach that point. So we get the distance. So when we multiply this, we'll get the height or the vertical distance. Page number 16, any doubt? Third, part 2 and 4. The magnitude of the force on the man due to an air resistance. So for the movement of the man from A to B, determine the decrease in gravitational potential energy. So if we need the decrease in gravitational potential energy, which will be mgh. So gravitational potential energy will be equals to mgh. The mass is there, the gravity and the height. When we multiply, we got the decrease in gravitational potential energy. Now we need the magnitude of the force on the man due to an air resistance. So as I mentioned that he's gliding or moving at a constant speed. So means what will happen to the remaining, like the gravitational potential energy, that all the gravitational potential energy is now used to work done against the air resistance. So when we calculate this work done, like the gravitational potential energy, the mass which was 85, the acceleration due to gravity 9.81, and the difference in the height was 3,200. So we got this as 2.7 into 10 to the power 6 joules. That is a gravitational potential energy. Now, because he's moving at a constant speed, so when he's moving at a constant speed, so what means the kinetic energy is not changing. So what happened to the gravitational potential energy? all the gravitational potential energy is used to do a work done against the friction. His speed is not changing, so means the kinetic energy does not change. So all the change in the gravitational potential energy in this region is used to do a work done against the friction. So we can say the work done against the friction, which is equals to F into D, and that is equals to change in a gravitational potential energy. So the change in gravitational potential energy is 2.7 exponent 6. The resistive force we don't know. And the distance which he moved. So the distance which he moved, that is the total distance which we move on this surface. This was 47 was a speed meter per second, and the time he took was 2.8 minutes. So we have to convert into second. So it will be 47 multiplied by the time, 2.8 times 60. So that will give us the total distance which he moved on this path. And the amount of energy he used to do a work done against the resistive force, that is 2.7 exponent 6, or the change in gravitational potential energy. So if I need the force, so we'll simply divide that. So 2.7 exponent 6 divided by this value, we'll get how much resistive force is acting on the person. Is it clear, this one? So the resistive force will be 338 and the unit will be newtons. Then in part 4, the pressure of a still air at A is 63 kilopascal and at B it is 92 kilopascal. Assume that the density of air is constant between A and B. Determine the density of air between A and B. So pressure exerted by the fluid, we can use that formula, that the pressure exerted by the fluid is density, gravity, and depth. So the pressure which the fluid exert, that is density, gravity, and depth. So the change in the pressure was, it was at the base, it was 92 kilopascal, and here it is 63 kilopascal. So how much is the difference? We just subtract to know what pressure is this. The change in the height we already calculated, which was 3,200. The gravity is also constant, so we can work out the density. So the pressure divided by gravity and the depth, we get the density. So we can also apply this formula for because the change in the pressure equals to density, gravity, and depth. That is used for the fluid, we can use for the liquids as well as gases. Page 17, any doubt? The weekly homework was from page 15 to page 30. Part B2. Determine the time for the car to travel between the two ramps. So this will have the two components. Show that the car leaves the ramp at a vertical velocity of 3. So a car leaves the ramp with a velocity of 5.5 angle to the horizontal. The horizontal component is 4.6. So the horizontal component is 4.6 meter per second. We need the vertical component. If we need the vertical component, so we can use the Pythagoras theorem that the hypotenuse square is equals to base square plus the perpendicular square. The hypotenuse is 5.5 square, the base is 4.6 square, and the perpendicular we don't know, which is a vertical component. So it will be 5.5 square minus 4.6 square in a root. That will give us the perpendicular component of this velocity, which is about, we have to show it's about 3 meter per second. So we'll get the answer in that range. Then we did want to determine the time. So if you want to determine the time, what we will do, like we can divide this motion into two halves. That is one way. Or you can also use the equation of the motion So if you use the equation of the motion, like if I use S is equals to ut plus half at square, and I compare like it leave and it return to the same level. So when it returned to the same level, what is the vertical displacement? The vertical displacement is 0. U is the initial velocity, but what initial velocity will substitute? We'll substitute the initial vertical velocity. So what is the initial vertical velocity? That in if you're not able to get the answer for the first one, you can use this number as 3. How S is 0? Because we are taking the vertical motion. So if I'm taking a vertical motion, here the vertical component was 3 and the horizontal component is 4.6. If it land to the same level, if it return to the same level, it means the vertical displacement is 0. So the vertical displacement, if it return back to the same level, the vertical displacement will be considered as 0. So initial, we'll take the vertical component, which we calculated, it will be about 3, or 3 we can also use. So it will be 3 multiplied by time, we don't know, plus 1 by 2. Actually, because whenever you take a full motion, the value of the gravity you will always take as 9.8, negative 9.8. So we take as negative 9.8 and 10t square. So this will be 3t minus 4.9t square. When we simplify this, so 4.9t square is equals to 3t, t square, and this cancel out. So if we need t, that is equals to 3 divided by 4.9. So 3 divided by 4.9, that is about 0.61 second. So for a full motion, if it lands to the same level, the vertical displacement is always 0. What is another way of finding the time here? The another way, you divide the motion into two halves. First, you will find the time to reach the maximum height. First, you will find the time to reach the maximum height, and the total time will be double. So if I want to find the time to reach the maximum height, like I have the vertical component, which is 3 meters per second. Here, the vertical component is 0, and acceleration I will take as minus 9.8. So we use a formula V is equals to U plus AT. The final vertical is 0. The initial is 3 minus 9.8 into t. This will move other side. So minus 3 is minus 9.8. Negative cancel with negative. So 3 divided by 9.8. So when we simplify, it will be about 0.3. Not exactly, about 0.3. So this is a time it takes to reach the maximum height. So the total time will be double of this. So we just multiply by 2. That's another way of doing the same question. So either you consider the full motion, or you can find the time to reach the maximum height. Is it clear? Page 18, any doubt? Page 18, part 4 and C. Page 18, calculate the ratio of a kinetic energy at the maximum height and the kinetic energy at its leave the ramp. Look, when it leaves the ramp, what is the velocity here? It's 5.5. So we'll use a formula half m. The mass is not known, but half mv square. So it will be 5.5 square. But at the maximum height, it will have only the horizontal component. So what will the velocity? The horizontal component is 4.6. So at this point, the velocity will be 4.6 meter per second. So we use a formula half m and then 4.6 whole square. And we want a ratio, like this is at point ramp P. This is a kinetic energy at point position, like at ramp P, and this is a kinetic energy at the maximum height. What you just have to do, you have to divide them V is not maximum because remember, whenever a projectile is launched vertically upward, it will have the horizontal and vertical components here. Like the horizontal component is 4.6 and the vertical component is uh, 3 and the resultant is 5. We take the resultant when we need the kinetic energy. But at the maximum height, only the horizontal component is there. The vertical component is 0. So the result of 3.3 and 4.6 was 5.5. That was a kind we used to work out the kinetic energy. When a projectile is launched, its vertical component decreases. Eventually, it will be 0 at the maximum height. So we just have to divide, substitute the values and divide, we'll get the answer for this. M will cancel with M, so we don't need M. Because like if you substitute half mv square, your 4.6 will be the resultant velocity at the maximum height because there is no vertical velocity. At this point, the resultant velocity is 5.5, horizontal and vertical were there, but the resultant so the horizontal velocity was 4.6 meter per second and the vertical velocity was 3 meter per second. When the projectile moved, the air resistance, we ignore the air resistance. So because of the gravitational force, acceleration due to gravity, at the maximum height, the vertical velocity will decrease. Horizontal velocity, we assume there is no air resistance acting. So the horizontal velocity will remain constant. So what is the velocity here when it was leaving? So the kinetic energy will be 1 by 2 m 5.5 square. But at the maximum height, because only horizontal component, there is no vertical component. So the resultant velocity is only the horizontal velocity. That's why we took 4.6 whole square. And then we divide them, we get the ratio of the two kinetic energies. Is it clear now? So it's actually a projectile motion which you have to apply here. Then ramp Q is removed and the car leaves. Look, if we remove the ramp, if we remove this ramp, then obviously in a projectile motion, if we launch a projectile and it returned back to the same level, so the vertical component at the launching position will be same as the vertical position when it hits the ground, hits the same level. And the horizontal component does not change throughout the motion, it remains same. But what if it landed lower than the launching position? So it's obvious that the vertical component will be higher. So here it will have a vertical component and the horizontal component. Horizontal component does not change, but just when it lands, the horizontal component will be same, but the vertical component will be greater. And the difference is that when it is going up, the vertical component was acting upward. When it is coming down, the component will be downward. So whenever a projectile, in a projectile motion, whenever a projectile is launched from the certain height, or projectile returned back to the same original level, in that case, if we have the vertical component, like example, the vertical component was 3 meter per second. So when it returned to the same level, here also the vertical component will be 3. At the maximum height, the vertical component will be 0. But what if the projectile does not return to the same level? It landed below the launching position. So what will happen if it launched, like example, at a vertical component of 3 meter per second, but here the vertical component will be higher. It will be more than 3. It can be any number and it will be opposite because the direction is downward. When it is launched upward, the direction of the vertical component is upward. So when we remove this ramp Q, this projectile, which is acting like a projectile, it will have a greater vertical component. So if we start like sketch a graph, we don't have to mention the values. But what if, example, if I mention the value, so this is 0, 1 is there, 2 is there, and this is representing 3. This is -1, minus, say 5 boxes equals to 1. So 1, 2, and 3. But you don't have to write a number here as they did not ask. So example 1, 2, 3, 4, 5. This is 1. So if we start with this value, when the project, this is launched, the vertical component will be upward. It was 3 meter per second. The horizontal was 4.6 meter per second. So it is, but it does not land the same level. It landed below the point where we launched this projectile. So what will happen to the vertical component? The vertical component should be greater than 3. And because whenever projectile motion, it will always have a deceleration, which is same as the gravity. So it must be a straight line. So it means the vertical velocity will start with a positive value, positive number, and it will decrease. When it reaches a maximum height, it will be 0. And when it landed, it will be higher than the original one. So at this point, the vertical velocity is 0. At this point, the vertical velocity is 0. It means this is the maximum height. And then when it is landing, because it landed below the point where we launched this projectile, so the vertical velocity will be higher than 3. So that will be the shape of the graph. And why it is a straight line? Because it has a deceleration, which is same as gravity or a constant value of 9.8. Is it clear? Page 19. Any doubt? Page number 19. Page 20. Any doubt? Part 2. Calculate the magnitude of acceleration of a block at t is equals to 2 seconds. So we have the speed time graph is there, and if we need an acceleration to work out the acceleration of a velocity time graph, we use a gradient. And because it is a straight line, we want to determine the acceleration at t is equals to 2. But because it's a straight line, so I can take gradient of this line anywhere. Because it's a straight line, so I can take any 2 points. I can take the 2 points above this. I can take the 2 points below this. Or I can take 1 point above and 1 point below. That does not make difference. I'll get the same result because it is a straight line. So example, if I took 1 point above and 1 point below, so I took this as x1. So this will be x1 and this will be y1. And I took another point below, above this. So anywhere you can take, you can take the last point as well. So this will be x1, this will be y1, this will be x2, and this will be y2. And you just use a gradient of a velocity time graph. The gradient of a velocity time graph will give us acceleration. You can take 2 as well. Even one of the point you can take 2, you will get the same result. But whenever you are finding a gradient, take 2 points at least 5 centimeter apart. For a more accurate result, even if in some cases you have to draw a tangent, so draw a tangent at least 5 centimeter long. Then use your answer, show that the tension in a wire so tension is actually because we work out the acceleration. After working out the acceleration, we need the tension. As you can see for this drone, as it is carrying so tension is a force which to pull an object, weight is acting downward. So we know the resultant force is equals to ma according to Newton's second law. So what is the resultant force? The tension minus the weight will be equals to ma. Or if I need the tension will be equals to ma plus w. A is the acceleration which we calculated in the last part. M is a mass, which is mass of a block we can work out. So, and W is a weight which is already given 15 Newton. So we can work out what is the tension acting on this spring. Is it clear, this one? Page 21, any doubt? Part 4 and 5, okay. The wire has a cross-sectional area of 2.8 exponent 5 meters square, and it's made from a metal of a Young's modulus, which is 1.7 exponent 11 Pascal. And the wire obeys the Hooke's law. Calculate the strain. Strain is a change in length. So we did this yesterday about the topic, the Young's modulus. What is a Young's modulus? The Young's modulus is actually stress divided by strain. If I need the strain, so it will be the stress divided by the Young's modulus. The Young's modulus is given to us. And how to work out the stress? Stress is force acting on a unit area. So if you need the stress, like the sigma, it is F over A. Cross-sectional area is given to us. What about the force? So we calculated that force, we already calculated, like the tension, because if I need the stress on the wire, so I need the force on the wire. So what is the force on the wire? The force on the wire is a tension. And the cross-sectional area of the wire is also given. So first I will find the stress. How to find the stress? Stress is force over area. So in place of force, we will substitute the tension, which we calculated in our last part. And the area is already given to us. So force divided by area, we get the stress. And the Young's modulus is equals to stress divided by strain. So if I need the strain, so strain will be equals to stress divided by Young's modulus. Stress we calculated for this question, which is tension over area, and the Young's modulus is already given in the question. So when we divide them, we'll get the strain. Is it clear? But why can we use a resultant force? Why? Because whenever we talk about the stress, whenever we talk about the stress is always the force which we apply on the wire. So the force which we applied, the resultant force on the block will be the weight. Like example, the tension is acting upward and the weight is acting downward. Say that tension was example 20 Newton and say the weight was example 5 Newton. So what is the resultant force? The resultant force will be 15 Newton. But when we talk about the stress is calculated the total force which is applied on the wire, or by using a wire, what is the total force we applied? That's why we did not substitute the resultant force. The resultant will be 15, but the force which is applied by the wire will be equals to same as the tension. So whenever you're calculating a stress and you have the tension and the resultant force, you will always substitute the tension. Don't substitute the resultant force, because the stress is force acting on the wire or by the wire. using a wire divided by the cross-sectional area. So total force which is applied by using a wire is actually equals to tension here, not the resultant force. Resultant force will be the difference of the tension and the weight. Next is at some time after 3 seconds, the tension in a wire has a constant value of 15. State and explain whether it is possible to deduce the block is moving vertically after 3 seconds. So as you can see, aircraft used to move block only in vertical direction. The forces varies. Now, as I mentioned, it is the tension in this wire is 15. So if the tension in the wire is 15 newtons and the weight is also 15 newtons, so what is the resultant force? The resultant force is 0. If the resultant force is 0, can I deduce that either it is moving or it is stationary? I cannot deduce, because whenever the resultant force is 0, there are two possibilities. One of the possibility that it might be at rest, another possibility it may move at a constant speed. So we cannot deduce that it is at rest or it is moving at a constant speed, because whenever the resultant force is 0, then two possibilities are there. The object may be at rest or it may move at a constant speed. That's why we cannot say that this will be stationary, or we cannot say this will be moving at a constant speed. Next is page 22. Any doubt? Page 22. Page 23. Part 3. The ball leaves the table at time t equals to 0. For a motion of the ball between A and B, sketch the graphs, variation, the acceleration of a ball, and the vertical component of a displacement. So whenever objects are falling, the falling objects like the projectile motion, what we say acceleration is due to gravity is a constant. So if acceleration is not, so acceleration due to gravity is constant, so and it will be a straight line, which shows that the acceleration is not changing. But what about the vertical displacement? When we talk about the vertical displacement here, so velocity is increasing. This is a displacement, like when you launch something from a certain height, initially the vertical component is 0. But then what happened? Horizontal remain the same, but the vertical component start to increase. So in the beginning, and we want to make this is a vertical displacement. So vertical displacement graph, like because it is launched from a certain height. So when it is launched from certain height, the vertical displacement is maximum. So we'll start with a maximum value. But initially, and remember the slope of a displacement time graph represent the velocity. So in the beginning, the velocity is 0, so means it should be a horizontal line. Then what will happen? Velocity start to increase, so the slope should start to increase. So I will draw a slope is increasing. So this shows that the slope is increasing. Why the vertical component is 0? Whenever a projectile is launched from a certain height, the vertical component is always 0. When it moves downward, the vertical components start to increase. The projectile motion. So because this was a projectile motion, a projectile was launched from a certain height. That's why initial vertical was 0. So this shows that the initial vertical is 0. Then the vertical components start to increase. So the slope should increase. So how we represent a slope is increasing. So this is the way we can represent the slope is increasing. Why it is not starting from zero? Because the object was already at certain height. The vertical, it was having some vertical displacement. Like example, if I say this object was launched from a height of 2 meters, so what is the vertical displacement? The vertical displacement is 2 meters. Then it is coming down. So means when it is coming down, the vertical displacement is decreasing. And when it hits the ground, the vertical displacement is zero. Even, yeah, if you consider both graphs are possible. Another graph is also possible, as one of the student mentioned, why we cannot consider this 2 meter as a origin. Yes, you can consider this as a origin. So if you consider this as your origin, if you consider this as your origin, if I consider this as my origin, then what will happen? The vertical component will increase, vertical displacement increase, and the slope should also increase. So I will draw a graph like this. That's also fine. Acceleration is constant, but because it's a distance time graph, when we have a distance time graph and we want to show the object is accelerating, so we should draw, increase the slope angle, because the displacement time graph, the slope represent the velocity. So we have to show the velocity is increasing. So even if you draw a curve from the origin, that's also correct. You draw the curve showing this manner, because as I mentioned, what is the position, as we did not read the full question, but if they mention consider this point as a origin, if they consider like this point as a origin, then what will be the graph? The graph will be like this. But if I consider this ground as my origin, so initially it will have the vertical displacement, and the vertical displacement start to decrease, but the velocity is increasing. So I will draw a graph in this manner. Is it clear? So if I consider this as my origin, less than a minute left, I'll share another link and I'll continue this explanation of the graph, like what will be the shape of the graph. I'll explain. Join from the link.